Question says, a balloon filled with helium at 1 atmosphere of pressure has a volume of 10 liters, is released into the air. Before the balloon pops, it floats up to an altitude of approximately 10 kilometers, where the pressure is 0.262 atmospheres. What is the volume of the balloon before it pops? Assume the temperature is constant, which in real life it probably wouldn't be. All right, so essentially we have a balloon at 1 atmosphere of pressure and a volume of 10 liters. The balloon starts to float up, and eventually it's going to pop when it gets to an altitude of 10 kilometers, but we don't really care about the altitude. We care about the pressure at that altitude, which is 0.262 atmospheres. So the pressure change is from 1 atmosphere to 0.262 atmospheres, and the volume is 10 liters here, and then what is the volume at this lower pressure? So in this case, we're relating the variables of pressure and volume. We're keeping the temperature constant because it says assume the temperature is constant, and we're also keeping the moles of gas inside the balloon constant, right? There's no air being blown in or out, all right? The moles of gas inside the balloon are constant. So we need to relate these two variables. It turns out that both of these, pressure and volume, are on the same side of the ideal gas law, so they're inversely proportional. Or, just from common sense, if you take a balloon and you lower the pressure around it, the molecules inside are going to be able to push against it more and make it bigger. So lowering the pressure causes an increase in volume, and therefore you have an inverse proportionality. Mathematically, an inverse proportionality is written as multiplication. So this is P1 V1 equals P2 V2, and this is called Boyles Law. So now we need to plug in our variables. Our initial pressure is 1 atmosphere. Our initial volume is 10 liters. Our final pressure is 0.262 atmospheres, and our final volume is what we're trying to figure out when the balloon, its volume right before it pops, so V2. So we multiply the 1 by the 10, and obviously we're going to get 10, and then we divide by the 0.262, and we find that V2 is equal to 38.2 liters.